We're living in a cosmic graveyard. What if the universe isn't alive? What if everything you see, the stars, the galaxies, the endless night, is not a celebration of life, but a cemetery? We look at the cosmos and marvel at its beauty. The glittering constellations, the rivers of starlight, the galaxies spiraling like cosmic dancers. But what if this beauty hides a terrible truth? What if we are living in a graveyard? Most of the stars you see are already dead. Their light began its journey millions, even billions of years ago. By the time it reaches your eyes, the stars themselves may have burned out, collapsed, or exploded into oblivion. The universe is not a cradle of life. It is a mausoleum of giants, a silent expanse littered with the corpses of suns. And it gets darker. Entire galaxies have died. Their stars extinguished, their brilliance gone. What remains are black holes, neutron stars, and cold remnants drifting through eternal night. We call it cosmic evolution. But what if it's cosmic decay? Even life, fragile, fleeting life, cannot escape this fate. Civilizations rise and fall. Worlds flourish and perish. And in the end, everything returns to silence. The universe is vast, yes. But it is also old. Too old. And age brings entropy. The slow, inevitable march toward darkness. In this video, we'll explore the haunting truth of the cosmic graveyard. We'll journey through the death of stars, the ruins of galaxies, and the terrifying future that awaits all matter. We'll ask questions that pierce the soul. Are we living among the ruins of civilizations? Is the silence of the cosmos the echo of extinction? This is not just science. It is philosophy. It is horror. It is the ultimate confrontation with mortality, not just ours, but the universe's. Welcome to the graveyard. Welcome to the end of everything. The death of stars. Stars are the architects of the cosmos, the furnaces where elements are forged, and the beacons that illuminate the darkness. Yet, like all things, stars are mortal. Their lives, though measured in millions or billions of years, are finite, and their deaths shape the universe in profound and haunting ways. A star's life begins in a nebula, a vast cloud of gas and dust drifting through space. Gravity pulls this material together, compressing it until nuclear fusion ignites. Hydrogen atoms fuse into helium, releasing energy that makes the star shine. For most of its life, a star remains in this stable phase, burning hydrogen in its core. But stability is temporary. Eventually, the fuel runs out. When hydrogen is exhausted, the star begins to die. Its core contracts, heating up as outer layers expand. For stars like our Sun, this transformation creates a red giant, a bloated, dying star shedding its outer layers into space. What remains is a white dwarf, a dense ember slowly cooling over billions of years. Silent. Lifeless. But for massive stars, death is far more violent. When fusion can no longer sustain the core, gravity takes over. The star collapses in a catastrophic implosion, triggering a supernova, one of the most powerful explosions in the universe. In seconds, the star releases more energy than our Sun will emit in its entire lifetime. The blast scatters heavy elements into space, seeding future stars, planets, and life. Yet, the core survives, transformed into something extraordinary. If the star was moderately massive, it becomes a neutron star, a sphere so dense that a teaspoon of its material weighs billions of tons. If the star was truly colossal, the collapse continues until nothing can stop it. The core becomes a black hole, a region where gravity is so intense that not even light can escape. A tear in the fabric of space-time. These remnants, white dwarfs, neutron stars, black holes, are the tombstones of the cosmos. They litter the galaxy, silent witnesses to the grandeur and violence of stellar death. And they are everywhere. Most of the stars that have ever existed are gone, leaving behind these cold relics. The universe is not a glittering paradise of eternal suns. It is a graveyard of extinguished giants. Even the stars we see today are living on borrowed time. Our sun, serene and life-giving, will one day swell into a red giant, consuming Mercury and Venus, perhaps even Earth. Then it will cast off its outer layers, leaving a white dwarf to fade into darkness. Other stars will follow, each surrendering to entropy. The scale of this mortality is staggering. Every galaxy contains billions of stars, and every star faces the same fate. Some die quietly, others in cataclysmic fury. But all die. And with each death, the universe grows older, colder, and darker. This cycle of birth and death defines cosmic history. It creates beauty, supernovae painting the sky with brilliance, and horror, as black holes swallow light and matter. It forges the elements of life, even as it reminds us of life's fragility. We owe our existence to stellar death. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were born in the hearts of dying stars. Yet, this truth carries a chilling implication. The universe is running out of fuel. Stars are finite. Fusion cannot last forever. As eons pass, fewer stars will shine. Galaxies will dim. Darkness will spread. The cosmic graveyard will grow. In the next chapter, we'll leave the realm of individual stars and step into the ruins of galaxies, vast cities of suns, now fading into oblivion. The graveyard is not just stellar. It is galactic. Galactic ruins. Galaxies are the grand cities of the cosmos, sprawling metropolises of stars, planets, and nebulae. But like all cities, they age. They decay. And eventually, they die. When we look at the universe, we are not seeing a vibrant, eternal paradise. We are gazing upon ruins, the remnants of galaxies that have lived, collided, and perished over billions of years. A galaxy begins as a swirling cloud of gas and dark matter, collapsing under gravity to form stars. For billions of years, these stars shine, creating the luminous spirals and glowing cores we admire in telescope images. But star formation is not infinite. It depends on gas, the raw material of creation. And gas is finite. As galaxies age, they exhaust their reserves. Star birth slows, then stops. What remains are aging stars, burning out one by one. The Milky Way, our home galaxy, is still active. New stars form in its spiral arms. But even here, the pace is slowing. In a few billion years, the Milky Way will be a graveyard, a collection of dim red dwarfs, white dwarfs, neutron stars, and black holes. Its brilliance will fade into darkness. Other galaxies have already reached this fate. Elliptical galaxies, for example, are vast cemeteries of ancient stars. They contain little gas, no bright nebulae, and almost no new star formation. Their light is dull, their color reddish, the hue of stellar senescence. These galaxies are cosmic tombstones, marking regions where creation has ceased. Dark matter plays a silent role in this drama. Invisible yet dominant, it shapes the skeleton of galaxies, binding them together even as their luminous matter dies. Without dark matter, galaxies would disperse into the void. Instead, they persist as ghostly structures, frameworks of gravity holding the ashes of stellar life. And then there is cannibalism, the brutal process by which galaxies consume one another. Gravity is merciless. When galaxies drift close, they collide. Stars rarely crash head-on, but their orbits warp, their gas clouds merge, and their structures tear apart. The result is chaos, tidal streams of stars, shattered disks, and violent bursts of star formation that quickly burn out. Eventually, The two galaxies fuse into one, a larger, older, and often more lifeless system. Our own galaxy bears scars of such feasts. Streams of stars in the Milky Way's halo are remnants of smaller galaxies torn apart and devoured. In the distant future, the Milky Way will collide with Andromeda, creating a monstrous elliptical galaxy, a final resting place for trillions of stars. Cosmic decay is relentless. Over time, galaxies lose their vitality. Their stars die, their gas vanishes, and their light dims. What remains are ruins, majestic, yes, but silent. The universe we inhabit is not a thriving garden. It is a necropolis, a vast cemetery stretching across billions of light years. In the next chapter, we'll explore what happens when even light begins to fail, when entropy tightens its grip and the cosmos slides toward ultimate darkness. The end of light. Light is the language of the universe, the messenger that carries stories across billions of years. Every photon that touches your eyes began its journey long ago, crossing the void to whisper secrets of distant suns. But light is not eternal. It fades. And when it fades, the universe enters its final act, darkness. The cosmos began in brilliance. The Big Bang flooded space with energy, birthing stars and galaxies. For billions of years, starlight has illuminated the void, painting the heavens with beauty. But this radiance is temporary. Stars are engines of fusion, and engines run out of fuel. As eons pass, fewer stars are born. Existing stars die. Their light dwindles. Entropy, the relentless law of disorder, governs this decline. Energy spreads, gradients flatten, and usable power vanishes. The universe moves toward equilibrium, a state where nothing happens because nothing can. This is heat death, the ultimate fate of a cosmos that has spent its energy and surrendered to silence. Imagine the timeline. First, galaxies exhaust their gas. Star formation ceases. The night sky dims as brilliant giants vanish, leaving only long-lived red dwarfs, faint embers glowing weakly. Eventually, even these fade. White dwarfs cool into black dwarfs, invisible in the dark. Neutron stars and black holes persist, but they emit no light. The universe becomes a graveyard of shadows. Black holes dominate the late era. They consume matter, merge, and grow. For trillions of years, they reign as the last titans of gravity. But even they are not immortal. Through Hawking radiation, black holes slowly evaporate, shrinking until they vanish in a final whisper of energy. When the last black hole dies, the universe enters its true twilight. What remains? A thin mist of particles, spread across unimaginable distances. No stars. No planets. No warmth. No light. Time stretches toward infinity, but nothing changes. This is the dark universe, a silent expanse where existence itself becomes meaningless. The thought is terrifying. We live in a cosmos that feels eternal, yet its glory is fleeting. Every sunrise, every starlit night, is a privilege borrowed from a universe that is dying. The graveyard is not a distant future. It is already here. Most of the stars that ever shone are gone. Most galaxies are aging. Darkness grows with every passing moment. And yet, there is beauty in this doom. The death of light is not chaos, it is order. It is the final symmetry of nature, the quiet closing of a cosmic book. Perhaps, in that silence, there is peace. In the next chapter, we'll ask a haunting question. If the universe is a graveyard, what happened to its inhabitants? Could civilizations have risen and fallen, leaving behind nothing but echoes in the dark? Civilizations lost to time. The universe is vast, ancient, and silent. When we gaze into the night sky, we see billions of stars and countless galaxies, yet we hear nothing. No signals. No signs of life. This silence is haunting, And it raises one of the most profound questions in science: where is everybody? This is the Fermi paradox, the contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for their existence. The cosmos is 13.8 billion years old. Stars formed billions of years before our sun. If life is common, then intelligent beings should have emerged long ago. They should have colonized the galaxy, left artifacts, or at least sent signals. And yet, nothing. One possible answer is chilling: we are living in a cosmic graveyard. Civilizations may have risen and fallen countless times, their achievements erased by time and entropy. Advanced societies could have flourished on distant worlds, built empires spanning stars, and then vanished, victims of war, resource collapse, or cosmic disasters. Consider the scale of time. Humanity has existed for a mere blink, a few 100,000 years. Our technological age is less than 2 centuries old. Compare that to the lifespan of stars, billions of years. Entire civilizations could rise and fall in the time it takes for a single star to age. Their ruins would be dust long before we ever looked their way. Even if traces remain, they would be hard to find. Planets erode. Moons crumble. Artificial structures decay. Radiation and impacts erase evidence. After millions of years, even the grandest monuments would vanish. The galaxy could be littered with the ghosts of civilizations, invisible to us. Some theorists propose the Great Filter, a barrier that prevents life from advancing beyond a certain point. Perhaps intelligence is rare. Or perhaps technological civilizations inevitably self-destruct. Nuclear war, climate collapse, artificial intelligence gone rogue, these threats haunt our own future. If the Great Filter lies ahead, we may join the graveyard sooner than we think. Others suggest cosmic catastrophes as executioners. Supernovae, gamma-ray bursts, asteroid impacts, these events can sterilize planets in an instant. Life may struggle to survive in a universe that is, at its core, hostile. And then there is time itself. Even if civilizations endure for millions of years, they cannot escape entropy. Stars die. Energy dwindles. The universe grows colder and darker. In the end, survival becomes impossible. The graveyard claims all. This perspective reframes the silence of the cosmos. It is not emptiness. It is aftermath. We are latecomers to a party that ended eons ago. The music has stopped. The dancers are gone. Only the ruins remain, scattered across the stars, waiting for someone to notice. Could we find these ruins? Perhaps. Astronomers search for technosignatures, traces of advanced technology, like Dyson spheres or artificial signals. So far, nothing definitive has emerged. But the search continues. Each discovery of an exoplanet, each scan of the sky, is a step toward answering the question, are we alone? If we are not, then the implications are profound. It means life is fragile. It means intelligence does not guarantee survival. It means the cosmos is not a cradle, but a crucible, a place where existence is tested and often destroyed. In the next chapter, we'll explore the darkest monuments of this graveyard, black holes, the tombstones of stars, and perhaps the final vaults of cosmic memory. Black holes as tombstones. Black holes are among the most enigmatic and terrifying objects in the universe. They are not creators, but destroyers, the tombstones of stars, marking the places where brilliance collapsed into darkness. In the cosmic graveyard, black holes are the ultimate monuments to mortality. A black hole begins as a star. A massive star, far larger than our sun, burns through its nuclear fuel in a blaze of glory. When that fuel is gone, gravity takes control. The core collapses, crushing matter into unimaginable density. If the star is heavy enough, nothing can stop this collapse. The result is a singularity, a point where space and time themselves break down. Around this singularity lies the event horizon, the boundary beyond which nothing escapes. Not light, not matter, not even information. To cross this threshold is to vanish from the universe, swallowed by an abyss that defies comprehension. Black holes are silent predators. They do not announce themselves with light, they reveal their presence through gravity. They warp space-time, bending the paths of stars and distorting the fabric of reality. Entire solar systems can dance to their invisible tune. In the cosmic graveyard, black holes are not rare. They are legion. Every massive star that dies leaves one behind. Galaxies teem with them, millions, perhaps billions, lurking in the dark. At their centers, supermassive black holes anchor the structure of galaxies, shaping their evolution. These giants, millions or billions of times the mass of the Sun, dominate the cores of galaxies like monstrous hearts of darkness. Yet, black holes are not merely destroyers. They are archivists. When matter falls into a black hole, it does not vanish entirely. Its mass adds to the whole, its energy radiates briefly as it spirals inward. Some physicists speculate that information, the quantum imprint of what fell in, may persist, encoded on the event horizon. If true, black holes could be vaults of memory, preserving the last whispers of stars, planets, and perhaps even civilizations. This idea fuels profound debates. Does information survive inside a black hole? Or is it lost forever, violating the laws of physics? The answer touches the foundations of reality. If black holes erase information, then determinism falters. If they preserve it, then the universe may hold secrets in places we cannot reach. Black holes also challenge our sense of time. Near the event horizon, time slows. To a distant observer, an object falling toward a black hole appears to freeze, its final moments stretched across eternity. From the object's perspective, it plunges inward swiftly, crossing the horizon and vanishing into the singularity. This distortion turns black holes into paradoxes, places where time fractures and meaning dissolves. Could black holes be more than tombstones? Some theorists imagine them as gateways, bridges to other regions of space-time, or even other universes. Wormholes, if they exist, might lurk inside black holes, connecting distant realms. If so, then death could be a doorway, and the graveyard could conceal passages to unknown worlds. For now, these ideas remain speculation. What we know is stark. Black holes are the end of stars, the erasers of light, and the architects of darkness. They are the punctuation marks of cosmic history, closing chapters with silent finality. And yet, they are beautiful. Their gravity sculpts galaxies. Their mergers ripple space-time with gravitational waves, ringing the universe like a distant bell. In their violence, they create order. In their silence, they inspire awe. In the next chapter, we'll turn inward, to the human mind. Why does the thought of a cosmic graveyard unsettle us so deeply? What does it reveal about our fears, our hopes, and our fragile place in the infinite? Human psychology and cosmic horror. The idea of a dead universe is not just a scientific concept, it is a psychological earthquake. It shakes the foundations of meaning, purpose, and identity. When we confront the reality that everything, stars, galaxies, life itself, is doomed to fade into darkness, we encounter a terror unlike any other, cosmic horror. Humans evolved to seek patterns, to find safety in permanence. The sun rises, the seasons turn, life renews. These rhythms comfort us, creating the illusion of stability. But the universe does not share our illusions. It is vast, indifferent, and mortal. Its grandeur hides a truth that chills the soul: everything ends. Why does this terrify us? Because it renders our struggles, our triumphs, even our loves, temporary. We cling to meaning, yet entropy mocks our efforts. Civilizations rise and fall. Stars ignite and die. Galaxies bloom and wither. In the end, nothing remains. This is the abyss, the confrontation with ultimate futility. Existential dread emerges when we realize that not only will we die, but so will everything we know. There will be no eternal monuments, no cosmic memory. The universe will not remember us. It will not care. It will dissolve into silence, and with it, every story ever told. This thought breeds two responses: despair or defiance. Some retreat into denial, clinging to myths of immortality or divine rescue. Others embrace rebellion, seeking meaning in the face of meaninglessness. Camus called this the absurd, the tension between our hunger for purpose and the universe's indifference. His answer was simple: revolt. Live fully, even as the void looms. Cosmic horror also reveals a paradox. Life exists in a dying cosmos. Against entropy, biology builds order. Against darkness, consciousness creates light. We are fragile flames flickering in a storm, yet we burn. This defiance is beautiful and tragic. For all our brilliance, we cannot escape the graveyard. Art and literature echo this terror. From Lovecraft's visions of indifferent gods to modern science fiction's tales of heat death, creators explore the psychological impact of cosmic mortality. These stories resonate because they mirror our deepest fear, that existence is temporary and the void eternal. Yet, within this fear lies wonder. The fact that we can contemplate the universe's death is astonishing. We are matter that knows it will perish, yet dares to dream. Perhaps meaning is not given, perhaps it is made, carved from chaos by minds that refuse surrender. In the next chapter, we'll explore how ancient myths grappled with these truths, weaving narratives of endings and rebirths long before science revealed the ultimate darkness. Ancient myths and modern science. Long before telescopes revealed galaxies and physics explained entropy, humanity told stories about endings. Myths of eternal darkness, cosmic battles, and apocalyptic cycles haunted ancient cultures. These narratives were not mere superstition, they were early attempts to grapple with the same truth science now confirms: everything dies. In Norse mythology, Ragnarok foretells the twilight of the gods. The sun is devoured, stars vanish, and the world sinks into chaos before rebirth. Hindu cosmology speaks of Kalpa, vast cycles of creation and destruction, where universes bloom and dissolve like cosmic flowers. The Greeks imagined Nyx, goddess of night, and Erebus, the primordial darkness that preceded all things. These myths echo a universal intuition: light is fragile, and darkness inevitable. Why do these stories resonate across cultures? Because they reflect existential fear. Ancient people watched stars rise and set, seasons change, and empires fall. They sensed impermanence. They saw death everywhere, in nature, in history, and projected it onto the cosmos. Myths gave shape to terror, turning chaos into narrative. Modern science strips away metaphor but keeps the message. Cosmology tells us the universe had a beginning, the Big Bang, and will have an end. Heat death, the ultimate triumph of entropy, mirrors mythic visions of eternal night. Black holes, devouring stars and swallowing light, are the dragons of our age. Dark energy, accelerating cosmic expansion, is the invisible force pulling everything apart. The language has changed, but the story remains: creation, decay, oblivion. In this sense, science is the new mythology. It offers explanations grounded in evidence, yet its implications are as haunting as any ancient prophecy. The equations of thermodynamics are our modern runes, predicting a future where galaxies fade, stars die, and time stretches into silence. The myth of Ragnarok becomes the physics of heat death. The Hindu cycle becomes the oscillating universe hypothesis. The fear persists, only the symbols differ. This continuity reveals something profound about the human mind. We crave meaning in the face of mortality. Myths once gave us gods to blame, rituals to perform, and hopes of renewal. Science gives us data, probabilities, and cold inevitability. Both confront the same abyss, the fragility of existence. Yet, there is beauty in this confrontation. Myths inspired art, poetry, and philosophy. Science inspires wonder, exploration, and technological dreams. Perhaps these responses are not opposites but siblings, two ways of resisting despair. Where myth sang of rebirth, science searches for loopholes, wormholes, multiverse, quantum escapes. Where myth imagined gods surviving the storm, science imagines consciousness transcending biology. Still, the graveyard looms. Whether told in sagas or written in equations, the ending is the same: darkness wins. The question is not whether the universe dies, but how we live before it does. In the next chapter, we'll face that question head-on. What is the future of everything? When the last star fades and the final black hole evaporates, what remains, and does it matter? The future of everything. What happens when the last star dies? When the final flicker of light fades and the universe sinks into eternal night? This is the ultimate question, the endgame of existence. The timeline of cosmic death is staggering. First, star formation ceases. Galaxies exhaust their gas, and new suns no longer ignite. The night sky dims as brilliant giants vanish, leaving only faint red dwarfs. These embers glow for trillions of years, but even they cannot burn forever. When the last dwarf fades, starlight ends. What remains are remnants: white dwarfs, neutron stars, and black holes. For eons, black holes dominate, consuming matter and merging into titanic singularities. But even they are mortal. Through Hawking radiation, black holes slowly evaporate, shrinking until they vanish in a final whisper of energy. When the last black hole dies, the universe enters its true twilight. This is heat death, the ultimate triumph of entropy. Energy spreads so thin that no work can be done. No stars. No planets. No warmth. No life. Matter decays into subatomic particles, drifting through an ever-expanding void. Time stretches toward infinity, but nothing changes. The cosmos becomes a silent ocean of darkness. Is this the end? Or could it be a beginning? Some theorists imagine exotic possibilities. Quantum fluctuations might spark new universes, budding from the corpse of the old. The multiverse hypothesis suggests that our cosmos is one bubble in an infinite foam, and when one bubble pops, others rise. Perhaps death is not final, but cyclical. Perhaps endings are seeds. Others dream of escape. Could advanced civilizations harness black holes, tap dark energy, or migrate to newborn universes? These ideas blur science and speculation, but they reveal a truth: the hunger for survival is eternal. Yet, even if rebirth occurs, it will not save us. Our species, our world, our story, all will vanish long before the last star dies. The graveyard claims everything. And in that silence, meaning becomes a question, not a given. What does it mean to live in a universe that dies? Perhaps meaning is not found in eternity, but in moments, in the fragile beauty of now. We are sparks in the dark, brief and brilliant. That brevity does not diminish us. It defines us. The future of everything is oblivion. But within that truth lies wonder. We are matter that knows its fate, yet dares to dream. We are voices in the void, singing before the silence. And maybe, just maybe, the silence will not last forever. Maybe beyond the graveyard, something stirs, a new dawn, a new cosmos, a new story. Until then, we live. We love. We imagine. And in doing so, we defy the darkness.